So next generation of computers, that's 1946 to 1957. That's the first gen computers. So first generation of computers were used for calculations related to military projects, scientific research, and business data processing. So as we saw right in the pre-computer age, we already saw computers. Now, these were not general purpose computers. These are computers that could only do very specific things. So, for example, in cryptography, we didn't consider those general purpose because all they did was crack codes. So first generation of computers were now more general purpose. But there is still pretty much dinosaurs, right, in the scale of the computer history. So they were enormous, just like dinosaurs. They actually took up an entire room. That's how big they were. The technology they relied on was vacuum tubes. So these were now electrical computers. Vacuum tubes are a very early piece of electrical engineering technology. So if you wanted to program the computer, you actually had to pull out a bunch of cables and put them in to these different slots every time you wanted to use the computer. Once you did all that rewiring, it could really only solve one problem at a time. So the calculations it could do 5,000 additions per second or 357 multiplications per second. If you become a computer programmer, you actually take a course. I took that course on computer hardware. And it actually explains, why additions are easier to do, why multiplications more computer intensive. And these additions per second, right, even though this is an old computer and definitely not as impressive as modern computers, was way better than a human, right? So computers, they had that accuracy, that ability to do things not just accurately, but also quickly. So those repetitive tasks. Of course, they weren't really convenient just yet in this first gen, right? So ENIAC was the world's first ever general purpose, fully electronic computer. Again, there were some computers that predated ENIAC, including electrical ones. Remember, Babbage was not electrical, it was mechanical. But the first general purpose computer was, of course, going to be ENIAC. So it was built in 1945. It stood for Electronic Numerical Integrator and Computer. It weighed over 30 tons and filled a large room, as is common with first generation computers. And it used 18,000 vacuum tubes. So you can see actually the cables here, the little slots. So you would have to take out those cables and move them around every time you wanted to solve a new problem. Next generation of computers is 1958 to 1963. So second generation of computers, the trend we're going to see across these generations is they get smaller, they get less expensive, and they become more efficient. So, you get your cake and you eat it too. You get everything with the next generation. So the reason they were smaller and less expensive was because of a new electrical technology called transistors. So a transistor was an electronic switch that could turn a signal on or off. So we talked about data. In that data slide, we had those zeros and ones. So once we learn about data, once we learn about hardware and software, we're going to learn that zeros and ones, they represent electrical signals. Zero means off, one means on. And you put all those signals together, all those zeros and ones together, you can actually represent a song, colors on a screen. Of course, we'll take a deeper dive on that much later on. So let's see. Let's return back where we started. All right, so second generation of computers, transistors were the ones that made this second generation possible. And take a look at those operations per second. We've now, multiplied 3x, 4x times. We could do a lot more operations than we could before. The input for some of these computers was actually punch cards. So it was like this paper, and you would punch little holes in it to tell the computer what to do. I actually had a student in my 101 class, my in-person class this past year, that actually used punch cards. He was old enough to actually live through that era. That definitely predates me. I'm not old enough for punch cards. So the output was also on punch cards or printouts. You could use magnetic tape for storage. Remember, storage was one of the 4 components of computers. Hard drives and programming languages were first introduced in this generation. So if you're going to become a programmer, right, if you want to tell the computer what to do, you learn a programming language. We're going to take a deep dive on all these concepts across this term. So second generation of computers, an example is the IBM 1401. So this was a business computer introduced in 1959. So of course, using transistors instead of vacuum tubes. It was popular for business uses such as payroll, accounting, and printing. Of course, it's still really expensive, really big. You see all those components, right? You need an entire room to fit all of them. Nevertheless, it did become one of the most widely used computers in the 60s, and it helped transition businesses from manual processing, so from paperwork, into digital processing. Third generation of computers, that's 64 to 1970. So again, even more powerful, even more efficient, and of course, the electrical technology, right, is the fundamental reason we have these generations, right? First generation, vacuum tube. Second generation, transistors. Third generation, the integrated circuit. So a circuit could fit many transistors, resistors, and other electrical components onto a small piece of semiconductor material. For example, silicon is a semiconductor material. So because we could fit all these components on a small little chip, computers became smaller and more reliable, and of course more powerful. Check it out: 500,000 instructions per second. We're no longer using punch cards for input. We're now using keyboards and monitors to display output, for example. So keyboards for input, monitors for output, and then hard drives are now widely used for storage. So an example of a third generation computer system was the IBM System 360. So it's the first family of computers designed to be compatible with each other. So now you had multiple computers working in unison. So it was released in 64. Of course, used the circuits, the chips. It was scalable for both business and scientific use. It's standardized its peripherals. So those are like your keyboards, right? Your extra input-output devices across all its different models. And it became a major influence on the future of computer design, right? It's the reason we have keyboards, right? It's the reason we have monitors. All those components have stuck around. Even with our little smartphones, right? We still have keyboards on them. We still have screens on them.